P-H-Y, 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 P-H-Y. Physics. Welcome!
Welcome to another AP Physics Camp lecture. Today we're going to be reviewing speed versus velocity. No, Alex, it's not like saying flash versus the reverse flash. Let's try to focus here. We're going to actually be comparing and contrasting speed and velocity. So make sure that you take good notes and let's begin. Yes, Alex, you're on the right track. Both of these terms describe the motion of an object. For instance, let's say that your dog Candy decides to take yet another adventure by getting across the fence at your house. What if Candy's adventure takes a total of 2 hours and she travels all over the neighborhood for a total of 30 kilometers? How fast did Candy move? You're right, Alex. Candy moved pretty fast. She traveled 15 kilometers every hour, which resulted in 30 kilometers in 2 hours. That's right, Alex. The slope, which is rise over run of a distance versus time graph, represents the average speed of the object. For instance, the rise in this graph is 30 kilometers and the run is 2 hours. When we divide it, it equals to 15 kilometers per hour. You got it, Alex. The units of speed are seen as a unit of distance divided by a unit of time, which means we might see it as kilometers per hour or meters per second or even miles per hour. I guess you're right, Alex. Candy was speeding. However, let's focus on the term used to describe her motion, such as speeding, which is accurate because we focus on her total distance traveled over a given time, which brings us to the average speed formula. However, let's say that we take into consideration the direction in which she traveled, leading us to determine the final displacement she had from your house. Yeah, I guess you can think of it that way, in which something is moved from its original position. So in this case, we're referring to Candy's displacement as the final position minus her original position, which was your house. Good idea, Alex. Let's say that you asked a couple of your neighbors if they had a recollection of where Candy was last seen, and that one neighbor told you that they last saw her 3 kilometers north from your house 15 minutes after she left your house. Then another neighbor said that they saw her 30 minutes after leaving your house, about 6 kilometers south from where she was first spotted. Then 1 hour after leaving your house, she was spotted 10 kilometers north of her second sighting, and then was last seen 2 hours after leaving your house 11 kilometers south from her third sighting, totaling to 30 kilometers in 2 hours. But what was her change in position, also known as displacement? You're right, Alex. Delta means change in, which equals final minus initial. In this case, we're referring to the change in position. So we need to determine the final position, subtract the initial position, resulting in -4 kilometers. Good question, Alex. Displacement plays a role in velocity because its formula states that velocity equals displacement divided by time. So let's say that this time Candy traveled a total of 30 kilometers around the neighborhood, but ended up 4 kilometers south of your house after 2 hours. So in reality, her velocity is -4 kilometers per 2 hours, which equals -2 kilometers per hour. That's not a real thing, Alex. And remember, it's called speed limit, meaning it's referring to the speed of the object, not the velocity. Anyways, back to our main topic. Average velocity can be calculated by determining the change in position over a change in time. Yes, that's right, Alex. When we use a position versus time graph or displacement versus time graph, we calculate the velocity by determining the slope, which is why we refer to velocity as final position minus initial position divided by final time minus initial time. You got it, Alex. That's exactly it. Velocity is a vector, which means it consists of both magnitude and direction. In our example, Candy's average velocity was -2 kilometers per hour, due south. Now, the speed, on the other hand, is a scalar, which means it only consisted of magnitude, in which we said Candy's speed was 15 kilometers per hour. Not exactly, Alex. Candy's average velocity during the trip might have been -2 kilometers per hour, but that doesn't mean that her velocity was constant throughout the entire trip. For instance, let's determine Candy's velocity at the 0.25 hour mark during her trip. You're right, Alex. Candy's velocity was 12 kilometers per hour at this point in her journey, which was more than the average velocity calculated for her total trip. But what about between her first and second sightings? What was her velocity here? Notice the steepness of the slope here as velocity increases. Good question, Alex. The velocity is increasing. It's just doing it in a negative direction since Candy is moving towards the south. Now remember that the negative simply refers to the direction. Sure, Alex, maybe Candy saw a cat or something which may account for her sudden increase in velocity. Okay, now let's take a closer look between the second and third sightings. What was her velocity here? Yes, Alex, maybe the cat got away or something, and that's why she began to slow down, moving in a positive direction once again towards the north. Then lastly, from the third and fourth sighting, what was her velocity? Yes, Alex, this is the part where Candy was probably very tired and her velocity continued to decrease, but in the negative direction. Great question, Alex. The average velocity would be less because it's taking into consideration all of the changes in direction among these velocities throughout the trip, which led to a total displacement of -4 kilometers from her original starting point, which was your house, resulting in -2 kilometers per hour. Thus, would you say that Candy maintained a constant velocity throughout her entire trip? That's absolutely correct, Alex. Based on our analysis of this graph, we determined that Candy's motion continuously changed its slope, therefore was not maintaining a constant velocity. If it would have been constant, then it would have looked like a straight line towards the negative direction, in which using the same slope at any point of the line would be accurate, and in our case, that wasn't it. Good question, Alex. We can update this graph based on your neighbor's sightings of Candy so that we can have a more accurate representation of her speed throughout the trip. Thus, the graph would no longer look like a straight line. It would show that Candy's speed varied throughout, resulting in a changing slope. Alex, I think you mean steepness, which does change as Candy's speed changes throughout her trip, resulting in various slopes. I guess if that helps you remember it, but just remember that the steeper a line is, the closer that line is to becoming vertical, and the less steep lines are actually closer to becoming horizontal. For instance, let's label the first sighting of Candy as point A, then the following as B, C, and D. Notice the steepness of the line between 0 and A, then compare it to the line between A and B. Yes, Alex, the line is closer to becoming a vertical line than the previous one, so we could say that it has increased its steepness. Now, notice that this is the same trend for the position versus time graph, sometimes also referred to as the displacement versus time graph. Now, the major difference is simply that this type of graph shows Candy's movements in both positive and negative directions due to the slope representing velocity, which is a vector. Okay, notice the rest of the lines now. Tell me, which part of her trip was she moving the fastest? You're right, Alex. It was between point A and B, which was perhaps when she was chasing the cat. But what about the slowest? Yes, Alex, Candy's motion was the slowest between points C and D, when she was probably getting really tired and started to try to find her way back home, but missed it by 4 kilometers, ending up in this position and traveling a total of 30 kilometers. Okay, Alex, let's try to summarize what we've learned about speed and velocity. I guess you could see it that way, Alex, but let's try to put this in physics terms. Speed is a scalar, which means it only consists of magnitude, no direction, meaning you will not see a negative value on the distance versus time graphs because the slope is referring to speed, which is distance divided by time. Now, as for velocity, this is a vector, which means it consists of both magnitude and direction. Thus, in a position versus time graph, both positive and negative values are seen, since the slope refers to the velocity, which is change in position over a change in time, also referred to as displacement divided by time. This concludes our video lecture. Make sure that you took good notes, and that's it. Have a great one.